So hi everybody and welcome back to C++ tutorial series for absolute beginners. This is video 232 and in this video I want to show you an example of these principles, but for this I make an illustration and let's get started. So first of all we have here a stupid programmer and a smart programmer. The stupid programmer, it's me, and a smart programmer, it's you, but when I say you I don't mean you personal. Then the stupid programmer and the smart programmer should work together to write a code. And the job of the smart programmer is, because he is smart, to write the code. So let's say you are writing the code. The smart programmer is writing the code. And the stupid programmer's job is just to understand the code. So I have just to understand the code. And then we are doing this task. And we have here a problem. The problem, what is the problem? The problem is I'm stupid. And you are smart. And you write now a code because it's your job. And this code is very complex, but it works and it's perfect. So it do exactly the job task. It works. We tested it. It's nice. But like I said, the problem is I am stupid. I don't understand complex things. And you wrote this a little bit with complex things or with tricks and all with your smartness, and that leads to the problem I don't understand it. So what is the result of this behavior? And this behavior, when I say behavior, this is most time behaviors of programmers. The result here is let's say who failed here. Actually, when you watch it clearly, not the stupid programmer failed here because he could not understand the working code. Actually, the smart programmer failed here. Why he failed? Why the smart programmer failed? Even he created a code which works with tricks. It's complex, but it works with tricks and all fine. The reason is the task was you should work together. You should write a code which works, but the stupid programmer should be able to understand, and he don't take this in account. So with other words, the failure was here the smart programmer. He made a code which is not fulfilling the task. So the question is now, what has this with principles to do? And let me show you that. So first of all, let's reinterpret this word stupid and smart, because that's not the real meaning of here in this example. Because stupid here means more, in this context, means is a programmer from 1 to 100. So a representation of 1 of 100 programmer, and I am only one of this 100. And my job is to understand your code. Of course, I'm stupid at start, before I read it, because I don't know it at start, right? And the smart here means just one programmer. And this one programmer is you. And you are all time smart when you write the code because you wrote this code, right? That makes sense. And the next step was why you failed here is because you could not write a code that was able to understand by, let's say, 100 programmer. Out of this 100 programmer, let's say 70 don't understand your code because it was too complex or has other issues, and 30% still understand your code because, like I said at the beginning, your code works. It's just complex and has super tricks, but they understand it. So let me illustrate you this one now in the coding section, what this means. Let's say I'm now the smart programmer, because now I show you my code. And I showed you this all time in the last video. Here I wrote a code, very smart. You can see, very easy. But the problem is already before we start, I see already no comment, which means no using a comment means all the other programmers here, let's say we have 100, they are able to understand my code, because every programmer of this 100 can decipher my code. The problem is all these other programmers will say, hey, 70 programmers say, I will not waste my time to decipher your code because you could not write comments there. They say, what the heck are you doing? Why I should analyze your code because you wrote a crap code? So this means 70%, let's say say, I don't understand your code because it's already bad written. And the other 30% who understand your complex code means, yes, they spend their time, or let's say they waste their time, because no comments to decipher your code, and then yes, now I know what this one is doing. So you can see I broke one principle, not commenting the code. And why is commenting in general so important? Like I said, if you get better and better as a professional, you don't need to read even the code. You are reading more the comment. And why? For example, let me make here a side. A professional read this comment here, open file to and insert, and let's say open file, just open file. Then he don't need read the code, because this open file is a general task and he already probably know what the code will be like. So with other words, in this case, he don't need to see the code. He will not even read the code, and he's finished just by reading a little comment. But on the other side, when you have no comment, every programmer must decipher your code, try to waste their time just because there is no comment. So I hope you understand this. This is one of these breaking principles. And of course, there are much more principles. For example, it's automatically, when it's breaking one principle, this is also the bad side, you are breaking probably more principles at the same time. For example, if these programmers don't understand your code, it's probably also not simple. You can say, hey, is this code now simple? No, because there is no comments. Now we have to decipher and try to all time to decipher every line and see what this variable is doing. The job of this variable, there is no comment, and a comment should all time ask the question for what. So for what is this variable? It is a temp variable, yes, but for what? Why you need it later? Probably save temporarily anything, but I have no clue what, and so on. So you can see following the principles would lead to a very good code. And in my example here, that was the mistake of this smart programmer. In my case, I'm the smart programmer. And the question is now how we can solve it. Of course, now you should add the principles to solve it, not just make the bad code here, but we can solve this, right? And solving is like, okay, start adding comments. Start making the code simple. For example, don't use complex code, because here coupling has something to do with complex coding. Don't make this. Make simple code. Or use, I don't know, use other principles to make all these things. And when you do this, then your code will become, when you follow these principles, this code, what you have here, will transfer to this code which everybody will able to understand. So you as a programmer, your job was to write a code. It could be complex at start, but later you have to change it so that everybody understands it. And this is only possible when you follow most of these principles here, because most principles here do only one thing. They make the code simple, 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 easy to understand, easy to maintain, easy to follow, and all these things. The problem is you have to know them and then also know how to do this in code. And this commenting is just one. There are later how to, like I said, complexity. You can decoupling many complex parts and so on. But this thing I will not dive into deep, because I will stop here. There is so much to talk, but this should give you only just the idea what you have to consider. And my advice is try to understand some of them and then use them while you are coding. So yeah, not like me, comment here. It becomes much easier to understand what I'm doing here. And then use other principles as well. So for example, use here less coupling. You can see coupling is something with complexity. So if you have a high coupling, means more complex. Complex code is general bad. When you see a complex code, in general, it's bad. And there are only special cases where you really need complex codes. And these are these cases where you have limited resources. For example, embedded system, you can't write complex code. You can't write simple code, because simple code means also most time more lines. And for example, if you have limited resources, you need less lines. So you can see these codes will be most time complex, or take old codes. So for example, from the 90s, they had all time limited resource. For example, they should write on a disk that was 1.5 megabytes, a full program. Yes, they have limited resources. They write complex code because, like I said, complex code means also less lines, but on the other side, big problems in all other areas, which you see here. And with that said, I want to stop here this little presentation. If you have any questions, like all time, any comments, write it in the comment section. And in the next video, we continue with our insert, and we try to use some of these principles. Because I was all ready to go to break some of them. And I will explain you this in the next video. All right, with that said, bye, good luck, and have fun.